So before we get into our examples, I just want to recap quickly our exponent laws and the definitions that we've learned, because it's all very well us looking at exponents, but if we don't actually know what we're doing, then it really doesn't matter. So in grade 8, you learn 4 laws and 1 definition of exponents. Now, you don't need to be like too stressed about law 1, law 2, definition 1, whatever. You just need to know how to apply them. It's very rare that I'm ever going to ask you to write in words what the law is or whatever the case is. Ooh, excuse me. What I expect more, or what we as your teachers expect more, is that you can apply these laws. So like I say, you had 4 laws and 1 definition. So let's start with the first law of exponents that you learned, which dealt with multiplication. So this law told us that when we are multiplying the same bases, we need to add the exponents. So for example, if I had x to the power 7 times x to the power 2, my law tells me that I need to take those 2 exponents and add them together in order to get my simplified answer. So law 1, the multiplication law, tells us that we add our exponents when we are multiplying the same bases. Now, guys, that's really important. It has to be the same bases. You can't say x times y squared and give me xy to the power of 3. That's nonsense. It must be the same bases. So that was the first law that we learned. The second law that we learned, or that we looked at together, was that of division. Now, hopefully, we know that multiplication and division are inverses of each other. And that sort of then logically tells us that the law or the method is the inverse. So if we had something like x to the power 5 divided by x to the power 3, this division law tells us that we need to subtract the top exponent minus the bottom exponent. So the division law tells us that we subtract exponents. And like I say, this makes sense. The inverse of multiplication is division. The inverse of addition is subtraction. So it makes sense that these inverses work hand in hand. That then allows me to simplify this to just x squared. Now, law 3 and law 4 sort of go hand in hand. So I'm going to combine them here just to save some time. Also because it's very rare that we actually ever test law 3 by itself. We do sometimes, but you more need to be able to combine everything together. And these are the laws of distribution. Okay, now we know about distribution from our algebra section. We know what it means. We know that it means that we're working with a product, but this is essentially when we've got a power raised to a power, or an exponent raised to an exponent. So for example, I could give you something like x cubed to the power of 2. I'm raising something that already has a power to another power. This law tells us that we need to distribute. It's what the law tells, it's what the law says, it's distribution. So what we need to do here is we need to take the outside exponent and distribute or multiply it to the inside exponent. So we've got x to the power 3 times x to the power 2, allowing us to simplify this to x to the power 6. So here we are distributing our exponents. Now that is essentially law 3. Like I say, we don't really work with law 3 by itself. It is more the extension of law 3, which is law 4, where we've got multiple factors inside a bracket. So for example, I could give you 2x squared y to the power 5, all raised to the power 3. This is what we need to be able to sort of deal with more than the x cubed squared. What is important here is that you remember that anything without an exponent does have an exponent of 1. So that coefficient of 2 does actually have an exponent. And so when we distribute the outside exponent in, we need to remember to distribute it to our coefficient. And this is often where law 4 trips us up. So what we will have here is 2 to the power 3, x to the power 6, y to the power 15. Because once again, according to my law, I'm distributing the exponent. Obviously, you can simplify that a little bit more and just leave this as 8x to the power 6, y to the power 15. But those are essentially the 4 laws that you need to know. Okay, I'm carrying on with my thing right now. These are 4 laws. We then have definitions that follow on or sort of come as a result of these laws. Now, in grade 8, you don't need to know both. You only need to know one. And I'm going to explain that one that you need to know right now. So this is the first definition of exponents that we need to know. And that is the definition relating to the power of 0. I'll go back to spell definition. And so this definition is working with the power of 0. Okay, now, like I said, these definitions are not laws because they're not completely separate from what we've done here. They come from these laws. So the power of 0 definition actually comes from law 2. If we had something like x to the power 5 divided by x to the power 5, our second law of exponents tells us that we should subtract these exponents. But what we end up getting is x to the power of 0. Now we need to understand what that means. So if we take a little tangent here and we think about this, we know that whenever we've got something divided by itself, so 3 divided by 3, negative 7 divided by negative 7, 2010 divided by 2010, x squared divided by x squared, whenever we are dividing by itself, something by itself rather, it is always equal to 1. And that's essentially what we are doing here. X to the power 5 divided by x to the power 5 is x to the power 5 divided by itself. And so what that means is when we've got something to the power of 0, we are working with the value of 1. So this is why I'm saying it's not a law, it is a definition. It is coming from the second law. And now we are able to work with 0 exponents. Okay, there is another definition dealing with negative exponents, but technically that is a grade 9 concept. We don't do it in grade 8. You will eventually do it. Some of you might have already done it. But these are essentially the 5 rules that we need to know. So those of you who, let's not say arguing, but Sianda, you might have been taught 6 laws. Technically, you've been taught 4 laws and 2 definitions. You've probably been taught negative exponents. That's fine. As long as you understand that these are the rules you need to know. Luanle, I did distribute to the variables, yes. So if we go back to law 3 and law 4, the variable x has an exponent of 2. 2 times 3 is 6. I did distribute already. Right, so guys, I would take a screenshot of this because this is essentially like your information sheet for exponents that you need to be able to work with when we do these examples. Again, if you've been told that you have learned 6 laws, it genuinely doesn't make too much of a difference to me. I'm not going to nitpick over what's a definition, what's a law. As long as you understand that these are the rules you need to know and that you need to apply, you can call them whatever you want. Alrighty. So let's start with our first law, which deals with multiplication. So if we have a look at our very first example here, this is nice and straightforward. So I want you to try this by yourselves and give me an answer in the chat. What does 2a times 3a squared simplify to? So in the chat, I want to see your answers for this very first question. Nice and easy. What is 2a times 3a squared? Okay, guys, keep those answers coming. Remember to apply your laws. There's a reason we've done that. And this is what I'm saying now. Whether you're using laws, rules, what, I don't care. As long as you know what to do when given the situation, I'm happy. Right, good, guys. So if we just break this down, especially if this is not your favorite section in the world, and for most kids, it actually isn't. Most students don't do very well with exponents. And so this is why we're spending an entire lesson on it, because it is so important. Alrighty, so if we have a look at this, we know that we are multiplying values. And so what we need to be mindful of is the fact that we can apply SNV. Remember, SNV, signs, numbers, variables. This works when we multiply or divide, it doesn't matter, but do it step by step. Now, for most of you, probably, you can look at this and you know what your answer is, but that isn't an expectation. If you need to break it down, do so. So if we start with the S, the signs, we've got a positive times a positive, so we know our answer is positive. If we then move on to the numbers are the coefficients to your variables. So 2 times 3, which we know gives us 6. And then we move on to our variables. Our variables here, we just have a, so we've got a times a squared. Remember, this a has an exponent of 1. And so if you're going to apply your exponent law, you're saying a to the power 1 plus 2, which allows you to simplify this to 6a cubed. So this very first example, like I say, nice and straightforward. We've got 6a cubed. We have applied our exponent laws where necessary. We have applied our multiplication to numbers where necessary, and we've got a final product. But that's all well and good, but what you need to be able to deal with are more complex examples. So I want you to try this example B here for me. 4x to the power 13, y to the power 12, times 6x to the power 8, y to the power 30, times 2x cubed. Right, now again, like this is quite a step up from question A. Do it step by step. Start with your signs, figure out what your sign should be. Go to your coefficients, your numbers, figure out what that product is. Then move on to your variables. Figure out what your exponent for x and y will be. Go step by step. Right, I will wait for answers in the chat. Excuse me. But remember your S and B, and remember to apply your exponent rules. Okay, I haven't seen any answers yet. I'm waiting. Remember SNV. Think about what your products are here. Remember your exponent laws. Okay, I'm going to give you another few seconds. Okay, guys, we've got a few differing answers here. Not the end of the world, but again, you need to be making sure. So now, guys, when we go through this answer, please make sure that you are doing corrections. As Yolanda always says, you need to have written it down, and you need to be making corrections as you go. Right, so we're going to go through it here. Self-destructive people are just causing their own chaos. Right, so let's have a look. If we have a look at question B now, again, signs, numbers, variables. No need to rush it. Do it step by step. So if we think about the signs to start off with, everything here is positive. It means my product is positive. If I move on to the numbers, we've got 4 times 6 times 2. 4 times 6 is 24. 24 times 2 is 48. Then I move on to my variables. For grade 8, what we need to be careful of here is that I've got the variables of x as well as the variables y. So they need to be separate. They represent different values. We can't just lump them all together. If I start with my x's, I'm saying 13 plus 8 plus 3. That gives me a total of 24. So I've got x to the power 24. Moving on to my y's, I now need to add 12 and 30. So this gives me an exponent of y to the power 42. So some of those additions that I'm seeing there for the exponents, you need to correct. But we have applied our exponent laws, we have applied S and V, and we have simplified this to 48 x to the power 24, y to the power 42. So again, grade 8s, you need to be very mindful of addition, firstly, and you need to be mindful of your products. You're finding the products, or you are multiplying the coefficients, you are adding the exponents because of the rules that we have learned for exponents. All right, so now that you've done that, I want you to try question C for me. I'll leave question B up. Give question C a try. Here, the only thing I'm going to say to you is be very mindful of your signs. So again, be careful of your signs. Think about what happens when you've got a negative times a positive. Use your SNV. Excuse me. Remember that your exponent laws have to apply to the same bases. You can't just mix and match willy-nilly. And remember, when in doubt, SNV. Remember, grade 8s, whenever there is a variable or number, but in this case, it's more important for the variables with no exponent, they do actually have exponents of 1. So if you need to fill them in for yourself, do that. You don't want to miss adding an exponent just because you've forgotten about the 1. Right, would anyone like to raise their hand to explain how to do question C for us? Okay, Sianda.
Hi, ma'am.
Hi.
How are you?
I'm good. How are you?
I'm good. Okay, ma'am. For this equation, I was actually supposed to start with the what do you call this? What do you call these letters again?
The signs, the variables?
Yes. But then instead, I just started with the numbers.
Okay, that's fine. Whatever makes
So,
more sense for you.
so what I did was I said -2 times -3 times 4,
Okay,
which gives me 24. And
good.
then I said m to the power of 1 plus 1 plus 3 equals to m to the power of 5. Then I
Good.
said n to the power of 1 plus 2 plus 1 equals to n to the power of 4. And my answer is 24 m to the power of 5 and n to the power of 4.
Excellent. Well done. Right, so guys, there you go. Nice and simplified. One thing I want to point out, remember Sianda said positive 24. This is because if you go to your SNV, a negative times a negative is a positive, and a positive times a positive is a positive. So your final answer is going to be positive. When you get to your exponents, remember it's m cubed. So adding 1 plus 1 plus 3 is 5. And then on the flip side, it's n times n squared times n. So 1 plus 2 plus 1 gives us that exponent of 4 that Sianda gave us. Now, I'm perfectly fine with you going straight to the answer like I have done here. That's not a problem. If you want to do it step by step, also absolutely fine. But if you're doing this SNV sort of in your head and you're getting straight to an answer, there is no problem with that, but make sure that you are doing it correctly. Right, guys. I don't know if I had it. Okay. So just in case, there are those 3 examples. Take a screenshot. If anyone has any questions, now's the time to ask. Otherwise, we're going to move on and have a look at how we now apply our second law of exponents. So any questions, now's the time to raise your hand. Otherwise, you're taking screenshots and we're going to move on. Okay, and again, grade 8, it's like I cannot stress enough, firstly, how important the section is, and secondly, how much people struggle with this. I don't know why, and maybe it's just me because I quite enjoy exponents, but exponents is one of the one of the worst answered sections in an exam from like grade 10 to grade 12. And like in grade 12, you build a lot on these exponent laws. So it is actually even in grade 11. So it's so important that we get these basics. Oh gosh, sorry. First full day back at school and I'm exhausted. Lubanzi, the N stands for numbers. That's when you're taking the coefficients and you're multiplying them. Your name is this PC and I know it's not this PC, and so it's somewhere in the back of my head. Just remind me what your name is. Ma'am, will you lose marks if you don't add calculations? I'm assuming you mean if you have something like this where you've got absolutely no working out, you've gone straight to your answer. No. Generally, the mark allocations are actually for your answer. So this would be a 3-mark question, but we'd give you a mark for 24, a mark for m to the power 5, a mark for n to the power 4. So thank you, Senzo. And see, I knew it was somewhere there. So show you're working out if you feel you need to, but like for this one, you could go straight to your answer and the 3 marks would be allocated for everything in your answer. So it's not really a huge issue, but when they start to get more complicated, I would definitely show you're working out, because as Sianda's now put there, if for whatever reason you've gone wrong somewhere, if there's no working out, there's no chance of you getting marks. However, if there is working out, at least we can give you some method marks somewhere, hopefully. All right. Okay, guys, so let's have a look at how we apply our division laws. So I've given myself so much space here. Clearly, I was scared after the last few lessons. If we have a look at something like question A, remember our division law tells us that we take the top exponent and subtract the bottom exponent. So very quickly in the chat, I want you to tell me what question A simplified answer is. What is x to the power 18 divided by x to the power 12? Good, grade 8s. Well done. Right, so nice and easy. Our exponent law tells us to subtract these exponents, so 18 minus 12, and so you get x to the power 6. You don't have to do this. So personally, I don't do this. I do it slightly differently. I say, okay, well, I know this means that I've got 18 x's in my numerator, and here I've got 12 x's in my denominator. Whenever you've got the same thing in your numerator and denominator, you can essentially simplify. You can cross cancel. So all 12 of these cancel with 12 x's in my numerator, leaving me with 6, hence x to the power 6. But however you want to do it is completely up to you. I prefer cross cancelling. To me, it's much easier than applying the law, but that's also just me. If you're happy applying the law, apply the law, no problem. Alrighty, so I want you now to try for me question B. So on the chat, I want to see answers for question B. Question B is 2xy squared divided by 4xy. So give it a try. Let's see those answers on the chat. I'll tell you right now, your answer should be a fraction. That's my one and only hint. Your answer should be a fraction. Remember what your exponent law tells you to do when you divide. Some of us are forgetting what our law says. Our law says that we subtract exponents, same as what we did in question A there. I appreciate that we're correcting ourselves as we go along. That's very good. And remember, grade 8, when we go through it, you should be marking your work, making corrections, making sure you've done it correctly if you haven't. Okay, we seem to be getting there. Still some mixed answers. Let's have a look. So I'm going to do this one. So SNV, signs, numbers, variables. To start with the signs, we've got Vio, hang on, you're on the right track. Signs, we've got positive divided by positive, so I know my answer is positive. I don't need to think too hard there. Then I move on to my numbers. Now, guys, the numbers are 2 divided by 4. So if I think about that, 2 divided by 4 is going to be a fraction. Your bigger number is in the denominator, which means you have to have a fraction. If you simplify this, you can divide both of these by 2, which means that your simplified answer here is a half, or 1 over 2. So you've got 1 in your numerator, 2 in your denominator. Now we need to move on to these variables. Now the variables, bear in mind, you've got 2 different ones, x divided by x, and then y squared divided by y squared. Now I've already spoken to you about what happens when we divide something by itself, but let's chat about it again. So if we take the x's here, we've got x divided by x. Technically, if you want to apply your law, that's x to the power 1 minus 1. And so that's x to the power of 0. But we know that that equals 1. So exactly as I said there in the chat, the x's cancel each other out. X divided by x is gone. It's 1. 1 doesn't change anything. 1 times a half is still a half. So it cancels. What we need to be careful of is the y's. So we've got y squared divided by y. Remember that y has an exponent of 1. And so what we have is y to the power 1, or just y. Now, guys, the next thing is, where do we put this? Does it go in the numerator? Does it go in the denominator? Where does it go? So this answer will always go where the biggest original exponent was. Sometimes I choose a lot of words. Where the biggest original exponent of the variable was. So in this example, our biggest exponent of y was originally in the numerator. So this answer of y to the power 1 needs to go into the numerator. That is where my leftovers need to go. Now this makes sense. If we think about this in terms of just the y squared over y, we'll get there in the end. Y squared divided by y. If you expand this, you've got y times y over y. One pair of y's cancel, leaving you with one y in your numerator. And so that is why that leftover sits there in the numerator. Now you've got a choice. You can either write it as 1y over 2. That's absolutely fine. Or you just write this as y over 2. Personally, I write it as y over 2, but it's absolutely fine to write it as 1y over 2. So very importantly, grade 8, that y has to be in your numerator. You had more y's in your numerator than in your denominator, so any leftovers once you've divided needs to go into the numerator. Okay. I'm talking too much. So take your screenshots of A and B. While you're doing that, if you have any questions, now's the time to raise your hand. Otherwise, we're gonna have a look at another one. So Nobiso?
Evening, ma'am.
Evening. Can you hear us? Or hear me rather?
So, ma'am, I was confused. Divided by 2. Yes, ma'am. So you divided the fraction by 2, while all the fractions by 2, or is it just this fraction?
Okay, so Nobiso, say that again for me. Sorry, I don't know if my internet was a bit weird. Try again.
I saw here that you divided the fraction by 2. So I was
Yeah.
asking, do we divide all the fractions by 2, or is it just this fraction?
It's just this one. So are you talking about that section over there with the orange?
Yes, ma'am.
Okay, so basically the reason I divided by 2 was to simplify. If you had a fraction, say, for example, of 3 over 12, I would now divide both of those by 3 because 3 is the common factor between both. So I'd be able to simplify that to a quarter. What you're doing is you're trying to simplify the fraction by dividing it by the highest or the biggest value that can divide into both.
Oh, okay, ma'am, I understand. Thank you, ma'am.
Good. So it's not every fraction. It just so happened that this one would be 2.
Yeah, I
Okay,
also
thank you, ma'am.
felt the network, I think it's not yours only. Some Wabisos are breaking there and there.
All right, guys, I hope you've got your screenshots. Umfa, I suppose you can stop coming to class, sure. But remember that these lessons carry on through the holidays and we're going to start next term with new work. So I definitely encourage you to continue coming to the lessons.
Oh yes, please do come to attend,
Yeah.
because really we don't want to miss anyone. Please, by all means, you need to attend our lessons, even during the holidays.
Definitely. All right, guys. So I want you to try this question C here for me. So again, be careful. We've got some negatives. We've got negative 2a cubed times negative b divided by negative 4a. Think about your signs. If you need a little hint, I would start by simplifying what's going on in my numerator. If you can simplify that, it does make your life easier. That's my hint. That's my only hint. Try. Let's see what you get in the chat. Remember still your SNV. SNV applies whether you're multiplying or dividing, as I've said. So break it down for yourself. I love watching you guys work. You're very entertaining. In a good way. You guys work hard. I see you paging back in your books, checking things. It's very good. Settle. What are we waiting for? Don't stress. Guys, remember, mistakes are absolutely fine. They happen to the best of us. Now, if you know you've made a mistake, figure out where you went wrong. If you don't know where you went wrong, but you know you've made a mistake, make sure you mark it when we go through. Okay, guys, let's have a look because we're getting some mixed answers here. So my advice is, oh golly, is start with whatever's going on in your numerator. So I wouldn't even stress about the division to start off with. I would just simplify this numerator first. So a negative times a negative is a positive. There is a coefficient of 1 in front of the b, so 2 times 1 is 2. And then you've got a cubed b. That is also being divided by your denominator of negative 4ab. Now remember that in your denominator, again, this is a negative 1 times the bracket. You are not distributing the negative 1 to 4, to a, and to b. That is one term in your bracket. So it distributes to the whole one term, hence negative 4ab. Now you can go and start to divide. So this is now where we need to go and have a look at SNV for ourselves. Again, if we start with signs, a positive divided by a negative is a negative. So my answer has to be negative. We've just dealt with the situation where we had 2 divided by 4. So hopefully we were paying attention and we know that that's going to be a half. And now we deal with the variables. A cubed divided by a. However you choose to do it, you're going to end up with a squared in your numerator. The b's are going to cancel because it's b divided by b. They cancel each other out. And so either your answer is negative 1a cubed over 2 or negative a cubed over 2. Both are absolutely fine. You don't have to write the coefficient of 1. You can, you don't have to. It's up to you. Why am I saying a cubed? I'm losing my mind. A squared. I even wrote a squared down on the previous step. Alrighty, so whenever you have a situation like this in C where you've got quite a bit going on in your numerator or denominator, simplify it. Make it easier for you in your next step to actually go and simplify further. Alrighty, so what that then means is I want you to try D. I just want to move this up so you can see it all. All right, so you've just done C. D is quite similar. I want you to give D a try. Answers in the chat. We'll see what we get now. Avio, back yourself. Sometimes we are wrong, and that's absolutely fine. But if you have confidence in your answer, back yourself. And if you were wrong, that's also okay. I'm still wrong in this. I don't even know how many years I've been teaching now. I still get things wrong. It's okay. Sometimes we just have a moment, and that's fine. We correct ourselves, and we figure it out better next time. Okay, so answers for D. Good, grade 8s. Keep them coming. Doing really nicely. Right, who'd like to raise their hand to explain question D for us? Okay, Teto.
Hello, ma'am.
Hi.
So, ma'am. Okay, let's do this.
Step by
Ma'am,
step.
so first you start off with the numerator because there's a lot of stuff there that you have to fix. So I ended up multiplying -8 by 2. So I had -16.
Good.
Then I just added everything else in there. So I had -16 b squared a.
Oh, if
And
you
that
wrote it
was
A squared B, sorry, Teto. If you wrote it A and then B squared, that's also fine. Yeah, then?
yes, ma'am, then that was still over 4ab squared. So I had
Good.
to divide. And then I ended up losing both variables because it was b2 minus b2 and a minus a. Then -16 divided by 4 ended up being -4.
Excellent. Well done. Guys, really importantly there, like Teto's just said, you lost or you divided away the variables. A divided by A is 1, B squared divided by B squared is 1. Those ones aren't going to change anything. -16 times 1 times 1 is still -16. 4 times 1 times 1 is still 4. So they fall away. Then, like Teto said, we had -16 divided by +4. So your answer needed to be negative. And you ended up then with -4. Penho, SNV, deal with your signs first, then your numbers, then your variables. It's just a little like, I think it's called an acronym, I never know. Just a little acronym to help you remember how to multiply and divide. All right, guys. So if you didn't get screenshots of C and D, take those screenshots. I don't know. I've lost my I've lost something. Anyways, right. We're going to do one more. You're going to try one more. Sorry, we'll skip straight past that. And then, no, we can try two more. So I know it's B and C. You're going to be absolutely fine with this number change.
Oh, sorry. I skipped to the end of the lesson. Running it.
That's
Sorry,
okay.
my apologies, guys. My apologies. We still have two more to do. Let's go, guys. Let's do this.
It's okay. It's cold. We're all tired. It's all right. But guys, before you do the poll, it's not the end of the world if you have done the poll already. It doesn't matter. But before you do the poll, I want you to try B and C. I'm going to give you 3 minutes because that'll take us to 5-2. I'll quickly go through them so you can mark, and then you'll do the poll, and then you will have a lovely one. A lovely Monday evening. Ovayo, don't stress about the poll. Yolanda was just super keen on poll. That's absolutely fine. Let's try these two and then we'll get the poll done. Okay, so guys, if you have answered the poll, it's absolutely fine. Really doesn't matter. But I want you to try these two before you go anywhere. Yeah, Lubanzi, I think let's renumber these. Because even for me, it's going to annoy me. Oh, sorry, everyone. Okay, so this is law 3, law 4, more law 4. The one that will catch you is B. I'm telling you now, it will catch you. So think carefully. And the reason it will catch you is what catches you every single time, the negative. Okay, guys, next thing. Please remember, you are not saying 2 times 5. You are multiplying the exponent of 2. The exponent of 2 is 1. Be careful. You cannot multiply coefficient and exponent. You multiply exponent with exponent. Okay, I'm going to give you 1 more minute to try. Don't stress if you're not done. But there are some important things I want to point out before you head along your merry way. Right, grade 8. So what you need to remember is that when you are distributing, that's the shortcut. What you need to remember is that this whole bracket to the power 5 is saying that we are multiplying this bracket 5 times. So this bracket is essentially being repeated in products 5 times. Now, we don't want to sit and expand this. As you can see, this takes a very long time. And this is why we have the shortcut of law 3 and law 4, right? So this law tells us that we just distribute. Now remember, it is exponent times exponent. So the exponent of 2 is 1. 1 times 5 is 5. So we've got 2 to the power 5. The exponent of x is 10. 10 times 5 is 50. The exponent of y is 8. Y times 5 is 40. So this whole thing simplifies to 2 to the power 5 is 32. So 2 times 2 times 2, 5 times. 32 x to the power 50 y to the 40. Where we often go wrong, and I pointed this out to you, is that we forget that we do in fact need to remember our coefficient needs to have the distribution happen to it too. Okay, so that's the first thing I want to point out. The second thing is what's happening in B. Now, once again, if we think about what's happening in B and we expand this, what we are doing is we are multiplying this bracket 3 times. Again, tedious to write out, but important because hopefully you're now going to see what happens with your signs. Now, guys, if you're multiplying 3 negatives, a negative times a negative is a positive, but a positive times a negative is a negative. And so what that means is your final answer here has to be negative. Now we can go and apply the distribution. So we distribute our outside exponent in, because we've already dealt with the sign by thinking ahead. If we take a to the power 12 times 3, that's a to the power 36. B to the power 9, and c to the power 39. It is negative because you multiplied 3 negative brackets. 3 negatives being multiplied together means that you're going to have a negative answer. So those are just 2 things I want to point out. Firstly, please remember, like in question A, the coefficient has to be affected by that exponent. It has to be. You can't just ignore it. Second thing is always take note of your signs. And the trick is, guys, and hopefully we remember this from like just basic exponent work. If your exponent is negative, If your exponent is odd, your answer will be negative if the value in the brackets is negative. If your exponent is positive, if your exponent is even, your answer will be positive. So I'm going to say that all again. If the value inside your bracket is negative, take note of your exponent. If the exponent outside is odd, your answer will be negative because you are multiplying an odd number of negatives, which means you're left with a negative. If the exponent outside was even, so if that had been a 4 instead of a 3, your answer would be positive because all of the negatives would cancel to make positives. Okay, so please just bear that in mind. Umfa, I hope your question is answered. Both Chippo and Teto have answered that for you. But basically, it's because you are multiplying 2 5 times. You are applying this exponent of 5. Let me just get a highlighter. Apparently not. This exponent of 5 is being multiplied to the exponent of 2. So we end up with 2 to the power 5, which is 32. Right, so guys, now you can do that poll if you haven't done it already. Although as I'm saying that, I see it's 100% completed, so ignore me. I will wait for the last 60 seconds for you guys to take screenshots, but once you have your screenshot, you are welcome to go, and we will see you on Wednesday. Luandle, I'm assuming you mean the one from the 2, the one for the exponent of 2. Remember, anytime you have a number or a variable without an exponent, there is an exponent of 1, we just don't have to write it.